change the world with my own two hands. Make a better place with my own two hands. Make a kinder place. Oh, with my own two hands. I can make a peace on earth with my own two hands, and I can clean up the earth, Lord, with my own two hands, and I can reach out to you.
Hi, I'm Leland D'Amico. I'm with Boston Green Realty. We're at Andover's first green home. I'm here with Dean Chongris from Ecologics Construction. Dean, tell us a little bit about what we have standing behind us.
What we have behind us, Leland, is not only Andover's first green home, but we have a state-of-the-art, eco-friendly home that's historically accurate to some of the older houses in the community. A lot of the detailing on this house comes from signature features taken from Andover's historic houses downtown. And what we've done here is we've combined all of that with a state-of-the-art building package and eco-friendly construction practices that give us basically the home of the future here, one like no other that's ever been seen in the area before.
Great. Let's go take a look at it.
Starting from the ceiling down, we've got a knotty pine ceiling with indirect lighting reflecting down on this white panel backdrop. These are all hand-built panels. All the details are hand-built to historically accurate dimensions and styles around the door. It's a craftsman style 6-light door with 2 side lights to change the image of the front of the house away from your conventional 6-panel colonial door. The columns were hand-built in place, tied up to the beam on the porch. The inside of the porch is wrapped with the crown molding, and the deck is finished with the mahogany decking. So from top to bottom, we have a dark floor, light walls, and a reflective ceiling that makes a really dramatic impression as the lights are on in the evening and your guests walk up to your front door in the house.
Let's go. All right, so we're on the first floor of this gorgeous home. Tell me a little bit about the size of it and what we got.
We've got a 4,100 square foot home here that will have the utility bills of a 1,500 to 2,000 square foot home. The reason it does, and the single most important feature in a house like this, is its exterior shell, or what we call in the industry the thermal envelope. The thermal envelope is how we use insulation in conjunction with siding, in conjunction with windows, and how that whole overall package tied together affects the performance on the inside of the house. The outside walls of this house are completely sealed with a pervious plywood known as the zip system. You can see that on our website. It's further detailed. With the zip system, the house is watertight and airtight before we side it and before we roof it. So by adding the siding and the roofing, we only add a further layer of protection to prevent any moisture or air infiltration, which would cause energy losses or mold growth in the house. That in turn provides a much more efficient home. It retains heat longer in the winter, it stays cooler longer in the summer, and this house actually requires 1/2 to 1/3 of the mechanical size and volume to cool and heat it than a conventional home would.
So Dean, tell me, compared to traditional construction, how many times over building code is something like this?
This house is going to be certified and rated at approximately 70% more efficient than what the building codes call for to this day. And it starts from the foundation, it goes all the way to the roof, and that's the thermal envelope we had mentioned earlier. The house is designed to minimize heat losses on multiple aspects, combine all of those systems together with an energy efficient window package, passive solar, heating and cooling, stack effect ventilation in the house. The house itself actually functions like a much smaller home when you get your gas bill and your utility bills, and indoor air quality is much better. It retains a much better climate control, and most importantly, the house resists a change in temperature. So if you were to take this house in a conventional house and shut the heat off, this house would stay warmer for days longer. When the springtime comes around, we get into summer and it goes from cooler days to warmer days. This house would have a much longer period before it came up to the acclimated temperature outside, and therefore we minimize the amount of days you need heat and we minimize the amount of days you need cooling. And when you do need heat and cooling, we're using a fraction of it to maintain the same temperature you would in a conventional home. So the operating costs of this home are drastically reduced by the improvements in the thermal envelope and the working characteristics of the house. So we, in essence, improved. We went with bigger walls, better insulation, and that in turn allowed us to go with a smaller heating system and a smaller cooling system. But then we upgraded that smaller cooling system to a high efficiency modulating system that wastes very little energy. It's up over 95% efficiency. So the combination of those three systems really make unbelievable headway in what it takes to operate a house in this day and age in this type of home.
Right. Well, let's give us an idea about some of the systems. For instance, you mentioned the zip system, right? All right, so Dean, what we have, this is what you were talking about, a zip system, right?
Yes.
Okay.
This is an exterior plywood that we use on the exterior walls and the roof. This green finish that you see is actually an impervious surface built right into the sheathing, right from the factory. These seams are all taped as we assemble it. So as we frame this house and we put this sheathing on, both the roof and the walls, we're watertight and we're airtight before we place any siding or any roofing on it.
And what does this replace that was used traditionally?
Traditionally, it was clapboards or plywood, and there was gaps in between, and the building wrap was used, but it was very inefficient. Wind-driven rain could get under the siding and infiltrate the walls, and then what happens is most homes have mold growing within the walls and they don't even realize it because they can't see it, they don't notice it, but it can slowly get worse and worse and worse depending on the severity of the leak. We use an extremely tight building envelope. All the windows are triple flashed, they're set in spray foam, they're set in silicone, and they're also wrapped in an ice and water shield. So wind-driven rain cannot get past our window system. Wind-driven rain cannot get past our exterior sheathing, and therefore air infiltration is also stopped so no cold air can leak into the house and waste energy. This whole system here is probably one of the single most important components of this house, is keeping that weather-tight shell, keeping the moisture out, and holding that heat in the house.
What's the warranty on something like this?
The zip system, as it states right on it, has a 50-year warranty. It's the same type of product. We use a version of it for the floor, which is moisture resistant, which is called Advantech, and that also has a 50-year warranty. So most of the building components that we're using here are components that have a substantial warranty behind them, substantial R&D. As far as the remaining construction of the house, the walls in this home has two walls. It has a 2x4 wall on the exterior and a 2x4 wall on the interior, which in turn provides us 8 inches of insulation in this wall system, which is basically twice the insulation you would find in a normal home. The way we configure the wall system minimizes thermal bridging of the exterior, and when you go with 8 inches of insulation versus 4, the effectiveness is not double, the effectiveness is actually tenfold combined with the system we use, and it's a compacted cellulose that goes in the walls dry, and every nook and cranny of the walls get filled, window headers are filled. A lot of spaces that were never insulated with fiberglass insulation bats are now completely covered. So there is not a single square inch on this exterior shell that air can get in, that moisture can get in, or does not have a minimum of 8 inches of insulation on it. The building code calls for an R11 in the walls, and our walls are almost R30. We're looking at R19 for the ceiling in the attic. We're over R100. And when we get to the basement, we'll show you some of the features that are included with insulation in the basement.
Let's take a look at some of the walls. We saw the first floor, which looks great. Let's go upstairs and check upstairs. So Dean, when you build a house this tight, ventilation, I'm sure, is pretty important, right?
Ventilation is key in a house like this. What we've done is we've designed this house to minimize the number of days that your AC needs to work, minimize the number of days that your heat needs to work.
Right.
Hot air rises naturally. I'm standing over the open foyer above the first floor, on the second floor, And the way this is designed is each one of these windows cranks out. They're up high near the ceiling.